Audio recognition speech sampling. The FFT, or fast Fourier transform, shape of a human voice recordings plays a central role in audio recognition, acting as a bridge between the time and frequency domains of sound. When we speak, our voices produce complex waveforms that vary over time. While these waveforms contain valuable information, it's often the frequency components that are more meaningful. The FFT process breaks these waveforms down into their individual frequencies, creating a spectrogram. This spectrogram is a visual representation of the different frequencies present in the audio at any given moment. For deep learning models, this transformation is critical. Just as we convert images into numerical formats for image recognition, the FFT spectrogram converts audio signals into a format that neural networks can understand and process. This tool helps us visualize and analyze voice recordings in raw and FFT forms. Let's explore it. Here we have the Record Audio button. When pressed, this will record our audio through the default computer microphone via the browser. Make sure to enable the browser microphone access. The audio length will be very short, around 2 to 3 seconds. Once the recording is finished, the tool will display the audio in raw signal waveform in this left window and its associated FFT, or fast Fourier transform spectrogram, in this right window. You can resample the audio data for playback and/or downloading using the resample ratio and these play and download data buttons. Let's try to record some sound examples. Let me press this button and say the word 1. 1. Here we go. We have the raw signal here and the FFT spectrogram here. Now, given the nature of the FFT spectrogram, we should have almost the same spectrogram shapes for the same spoken word. We can demonstrate this by recording the word 1 several times. 1. 1. 1. As expected, we find that the FFT plots are quite similar for the same word. Now let's try recording another word, 2, a few times. 2. 2. 2. 2. Note the similarity between the FFT plots again. Now let us resample this audio data with a ratio of 5, which means that every fifth signal element is sampled from the raw audio. Let's play this sample by pressing this play button. We hear the word slightly distorted. We can choose any resampling ratio we want. The main goal is to save storage space and bandwidth by reducing the audio resolution. Finally, we can download this audio using the Download Data button. The downloaded file is a custom file in JSON format containing some metadata and raw data values of the audio signal and the FFT spectrogram data. Let's see what this data looks like. So I'll press this button. It'll download, and I'll open the file in my favorite text editor. Notice that the file has some metadata attributes and a lot of numbers representing raw audio data and FFT. This covers how we can analyze voice recordings in raw and FFT forms. Please feel free to play with the tool by recording various voice segments and analyzing the raw and FFT plots and downloading the data.